All right, so we're going to talk about triggering soybean flowering today. I'm excited to share this information with you. We have so much amazing research going on in the soybean world, and these are some basics that are going to help prepare you for Rachel's talk. So I'm going to talk for the next 10 minutes or so about what triggers soybean flowering. And my number one objective is to really prepare your mind for Dr. Van's talk. When she presents on planting date and maturity group and the interactions between them, this information that I'm going to give you, if it's fresh on your mind, it's really going to make it easier for all of us to process the data that she's presenting. So why do soybeans flower? The number one trigger of soybean flowering is going to be how long the nights are. Now, that is because the longer the night, the closer we are to the dead of winter. And soybeans originated in a place that had 4 seasons, and one of those seasons was a true winter. And the only way a soybean plant can survive a wintertime is in the seed form. So it's a survival strategy by the soybean. And when the nights are getting longer, that's when the soybean plant senses that winter is coming and it needs to begin generating seeds so that it can survive. And we tend to refer to this term as short day plants. What we're really talking about is long night plants, but short day plants is a common term that's used. So building the seed factory. When a soybean plant first begins its growth, it's putting on leaves, vegetative structures, stems and branches, and what it's doing there is it's building the factory that it's going to be using to make the seed when it begins to run out of time and it has to produce seed before winter time comes. So as the plant develops this structure, it's very good at sensing the amount of time that it has left. It'll stay in that factory building stage as long as it can before it has to develop the seeds. So if we talk about how this works in our area, this is a graph of the Statesville region, and it applies through all of North Carolina. So what you can see here is on this side, it's the number of hours in the day. So the yellow is light and the gray is night. And then on the bottom, we have the months of the year. Now, at the vernal equinox, which is in what part of the year? What month does a vernal equinox occur in?
June 21st.
It's in March. It's in the 3rd week in March. The vernal equinox is the period of time where we have 12 hours of daylight and 12 hours of night. It's even. Does that make sense? Ring a bell? All right. Then as we move towards our optimal planting date, somewhere in the few weeks before and after May 1st, you can see the nights have been getting a little bit shorter and the days have been getting a little bit longer. Then as we move towards the summer solstice, which happens when? Right, June 21st-ish. We've got 14 hours of daylight, which is our longest day of the year and our shortest night of the year. So if it's the longest day of the year and the shortest night, what's going to happen from then on? The nights are going to get longer. So nights begin to get longer after the summer solstice. And remember how I said that's what triggers a soybean to begin flowering, is when the nights begin to get longer. Okay, so that's in our neck of the woods in North Carolina. In order for us to understand maturity groups, we have to learn a little bit more about what happens in the rest of the world. So for the next couple of minutes, I'm going to show you this video that I didn't make, but I did edit it down. And it's a really good graphic representation of how daylight changes in different areas of the world at different times of the year. So first you can see here, we've got the sun, and then we've got this face of the side of the earth that's facing the sun is in daytime. This side of the earth facing away from the sun is nighttime, right? However, if we were rotating on the axis and the axis was straight up and down, we'd always have 12 hours of day and 12 hours of night. That's not the case. Our Earth is tilted on its axis a little bit, and this is what causes all that variability throughout the year. So in June, you can see the daytime in the northern hemisphere. We have a lot more daylight in June in the northern hemisphere, and a lot less night. And as this Earth rotates around, I'd like you to keep your eyes on Florida and Alaska and compare the two. So you can see Alaska has, in the summertime, they have 23 hours of daylight on the longest day of the year. So their shift from day to night in throughout the year is very dramatic. Let's see what happens when we get to the other side of the sun in December, in the wintertime. We have a lot more dark. So in the northern part, if you look at, you can't even see Alaska because it's in night. On the longest night of the year for them in December, that's 23 hours of night. But Florida, closer by where we live, is much more moderate, right? So in the north, the higher north you get, the higher you get towards the 90 degrees latitude, the shorter the growing season and the more extreme the scenario. When you get closer to where we live in North Carolina, at a lower latitude, closer to the equator, we have a much more moderate change of seasons and we have a much longer growing season. Okay, so this really does have to do with soybean production. And let's take a look quickly at the comparison between where soybeans originated from in China and the United States. So this is a map of China. The gray area is China, where soybeans originated from. Their genetics started here, and then the black line around is, of course, America. And we're right around here, right? So we're closer to 35, 36 degrees latitude. And if you think about it, realistically, the climate in our area is much different than the climate in Minnesota or Wisconsin. And since soybeans are native to China, their genetics are adapted to all of these different types of growing environments. And the breeders in America have fit this system to accommodate the different latitudes. They designate these maturity groups. This is just to kind of make sense of the genetic variability that we have in soybean. And this is a historical map, so not a recommendation, but historically we plant these really early maturing varieties up in the north. They have a much shorter growing season, and then down here we've typically planted our later maturing varieties. So if you've ever planted, I won't ask this question, but if you've ever planted a really early maturity group that maybe isn't quite suited to our environment, like a 2 or 3, if you've ever planted them in North Carolina a little bit too early, if you've planted them in March, that night is it's sort of long in March, right? Before the summer solstice happens, the plants, through the chemicals and the genetics in their leaves, they perceive that as actually getting towards winter instead of getting towards summer, because that night length had triggered them to flower. Because they don't have any way of knowing where they are in the world. They only have a way of sensing how long the nights are and how the days are. So if you'll notice these maturity group lines, they're not totally straight, they don't totally line up. And that's because temperature is also a factor in flowering. The length of night is what triggers a soybean to flower. What regulates the pace of development is temperature. Temperature regulates the pace of development. So when I was a graduate student, one of the things I had to do was look at flower buds under a microscope, and I had to be able to determine when that particular bud switched over from the vegetative stage to the flowering stage. And they actually change shape. But you won't see that flower emerging by the visible eye for weeks after that. And what regulates the length of time that it takes to get from that really small cell all the way up to a visible flower is the temperature. The warmer the temperature, the faster the flower is going to develop. Basically, the soybeans are making hay while the sun shines, right? If they perceive that the temperature is favorable for seed development, they're going to try to get to that party faster, and they're going to try to flower and begin to make seed while they have good conditions to do so. So in summary, soybean flowering is really dictated by night length, and temperature is also a factor that contributes to how long it takes for a soybean to flower. And then there's going to be these interactions between maturity groups and planting dates that Dr. Van's going to talk about next. So none of this research was mine. I'm just summarizing it. But if you need more information on any of these, I have a lot of resources here available for you to take a look at. Any questions before we move on to Dr. Van's presentations?
I'll say that, probably
Turn
15,
it on.
20 years ago, Arkansas was promoting planting certain like trees and very early in the year, and they were trying to get them to harvest before the really extreme heat, and they had less irrigation cost or whatnot. So I didn't know if that was still a thing or not.
Yeah, so in Arkansas, they call it the ESPS system, the early soybean production system. Almost all of their acres sit in that system today. I don't think they're harvesting in July. I think they are planting early, and a lot of their harvest is still happening in August and September, but they are pushing the reproductive development period out of the most severe drought, which they generally have in August and September. At that point, they're already like late into the reproductive development stages. And we can do that. We can grow those early maturity groups in the South because why? Well, because the earlier maturing varieties need a shorter length of night to trigger flowering. And in the upper Midwest, where those maturity groups were bred to be adapted, they have a shorter length of night than we do. So we have the length of night that can trigger flowering across many maturity groups in the South, regardless of where they're adapted to.